Hi, this is Mrs. Abbott, and this is Algebra 1, and today we're going to be reviewing factoring trinomials. But first, let's take a look at what we've learned already. We've been using our factoring flowchart since we began this chapter. The first method we learned to factor was the greatest common factor method, where we divided all terms by a common number or expression. Then we've learned a couple of methods for factoring trinomials where they have three terms. The multiply and add method is used when we have a leading coefficient of 1, and the AC method is used when we have a leading coefficient that is not 1. So let's review those two methods today so that we can see how to tell when to use which method on which type of problem, because that seems to be our greatest difficulty right now. So taking a look at this chart, when we're factoring trinomials, first make sure they're in standard form, where our variable is in descending order of powers. We have ax squared plus bx plus c, where a and b are the coefficients and c is a constant. We're going to look at that leading coefficient of a. If that leading coefficient is 1, we're going to use the multiply and add method, where we are finding two numbers that multiply to equal c and add to equal b. We factor that straight into two binomials. If, however, that leading coefficient is not 1, we're going to use the AC method, where we find the product of a times c. We're going to split that b term, the middle term, into two parts, and then we're going to factor by grouping. As you can see, this method has a few more steps, so we only want to use it when we have to. Either way, our final factored answer will be the product of two binomials. So let's take a look at a couple of examples and review the two types that we've learned to factor trinomials using. So in our first problem, it is in standard form. Our leading coefficient is not showing, that means it is 1. And our chart tells us when that leading coefficient is 1, we're going to use the multiply and add method. We want to find two factors that multiply to give us negative 24 and add to give us positive 5. And once we find those two numbers, we go straight to our two binomials. So let's see, what two numbers can I multiply to give me negative 24? I could multiply 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Since my product is negative, I know one of these factors needs to be negative. I want a sum of positive 5, so I'm going to make the smaller one negative. And you can see that a negative 3 times 8 gives me the product of negative 24 and the sum of positive 5. I also know that v squared factors into v times v. So then I bring my two factors into my binomials. V minus 3 times v plus 8 is my factored answer. Now, if you recall from earlier in the chapter and last chapter, when we FOIL this, meaning we multiply our firsts, our outsides, our insides, and our lasts, we'll get the trinomial that we started with. And in that turn, we will know that this is the one and only correct factored answer. Now let's take a look at our second example. You can see our leading coefficient is not 1. In this case, it's 10. When our leading coefficient is not 1, we're going to use the AC method. So we're going to multiply our A times our C. And we're going to look for two factors that have a product of positive 35 and a sum of negative 37. From our chart, you learned, and from earlier in the chapter, you learned that we're going to split that middle term. The first term stays the same, and the last term stays the same. We're just going to split that middle term into two parts. And we're going to use our factors of 300 to find out what our two parts are. Anytime my product is positive, I know my factors will have the same sign. Since the sum is negative, I know that sign will be negative in both cases. Now 300 is kind of a large number, so let's work through some factors starting with 1 until we find our pair that adds up to negative 37. I could have 1 times 300, and if I work my way down with all the numbers that divide into 300, I'll find the correct pair. So I could have 2 times 150. I could have 3 times 100. I could have 4 times 75. I could have 5 times 60. I could have 6 times 50. 7 does not go into 300 evenly, 8 does not, 9 does not, but 10 does, 30 times. 11 does not go in, but 12 does. 25 times. I'm going to stop there because that's the pair that I need. So I'm going to turn that negative 37b into negative 12b minus 25b. So I've split it. I still have the same sum of negative 37b. It's just now two parts. Since I've created four terms, I'm going to use factor by grouping. That means I'm going to look for the GCF of the first two terms. That would be 2b. When I divide each of those terms by 2b, I would be left with 5b minus 6. And then I look for the GCF of the last two terms, which would be anytime that third term's negative, make sure you factor out a negative. So our binomials match. Divide each term by negative 5. That leaves me with a positive 5b minus 6 again. When I have the two binomials that match, I know I'm on the right track, so I'll factor those out like a GCF. 5b minus 6. And what was left over makes up my second binomial, 2b minus 5. Again, remember to FOIL to check your answer. It should be, and it will be, the same trinomial we started with, and we know that we have the one and only factored answer, and it is correct. Now for our last two examples, I want you to look at them, make sure they're in standard form. Ask yourself, what is that leading coefficient and which method does that tell me to use? Factor these two, check with your shoulder partner, and when you've agreed upon an answer, one of you can go to the front table and pick up worksheets for both of you. Those will be due tomorrow. Hopefully this has clarified the difference between the multiply and add method and the AC method, because again, multiply and add is much more efficient than the AC method, so you do not want to use the AC method unless you absolutely have to. Next time we'll be learning about special factor patterns. Homework is due tomorrow.